standard heat of formation is one other kind of delta H. So we've talked about multiple delta H's, right? There's heat of combustion, which is the heat released when a mole of something combusts. There's heat of solution, which is the heat released or absorbed when a mole of something dissolves in water. There's heat of fusion, which is the heat associated with a mole of something melting. So there's all these different delta H's. Here's our last delta H we're going to talk about, heat of formation, okay? And this little subscript here means formation. Okay, so it's basically delta H for a reaction in which any compound or thing forms from its individual elements in their standard states. Okay, what does that mean? Okay, what are the standard states? Temperature. Oh, I can't remember. It's 0 for gases. I think it's actually 25 for thermochem. Okay, and then pressure is 1 atmosphere, as usual. Okay, how do we know the faces of the elements in the reactants? Lulu? The periodic table that you can't see but have committed to memory. Good. Okay, so let's write out the formation reaction for solid NaCl. Okay, formation reaction, forming NaCl, solid from a reaction. So our forming NaCl means that's going to be our product. Okay, so Roman, what are reactants going to be? Okay, he says sodium. Good. Sodium, and sodium is normally a solid. And he says our other reactant is going to be chlorine. That's right. Emily, what state of matter is chlorine? Emily Takara, what state of matter is chlorine in normally? She says normally it's a diatomic gas, and she's dead right. Okay, is that a thing? Whatever. Chlorine. Okay, uh-oh. Now, can I just balance this and do a 2 here and a 2 here? Jaden? He says, heck no, Mrs. Prestwood, because a formation reaction is the enthalpy change for the formation of 1 mole of a substance. I can only form 1 mole of NaCl. Okay, well then Trevor, what do I do? And he says, I don't know, I guess you can do 1/2 of Cl2, and he's right. Okay, so this is where we break those rules we had before. You can have a fraction as a coefficient. Good work, team. Okay, what if we're trying to form a free element in its standard state? For example, write out the formation reaction for O2 gas. Okay, if you're forming O2 gas from its elements in their standard states, Shreya, what's our reactant going to be? She says O2 gas. Well, what's happening there? Nothing. So it's 0. There isn't a formation reaction for something from its elements in their standard states if it is an element in its standard state. Everything else will have a value for this, okay? And they can mostly be looked up, actually. Okay. Onwards. All right. All right. We can use the heats of formation to find delta H for an overall reaction. How do we do it? We do the heats of formation of the products minus the heats of formations of the reactants, okay? And we multiply by coefficients because heats of formation are in kilojoules per mole of the thing that was formed, and we want our delta H to just be in kilojoules. You can also think of it as kilojoules per mole reaction, but just kilojoules is fine. All right, so what does that even mean? How do we apply this? What is delta H for this reaction? Okay, we're going to do, we're going to do products minus reactants, okay? This symbol here is capital sigma, and it means sum of, or summation. Okay, heat of formation of the products. We only have one product, it's CO2 gas. Its heat of formation is negative 393.5. So we're going to say, I'm going to write units just because it might help you, but it might make it more confusing. You do not have to write units. Negative 393.5 kilojoules per mole times 2 moles of CO2, okay? We would add another product if there was one. That's what this sigma means, but there isn't one, so we're done with the products. We're going to do minus the heat of formations of the reactant. So again, I'll do close parentheses, okay. Again, we're going to do 2 moles of CO times its heat of formation, which is negative 110.5 kilojoules per mole, Okay, moles is going to cancel, close parentheses, plus the heat of formation of oxygen, which is 0. If you would like to write 0 times 1, you can do that. If you want to leave 0 out, you can do that. Okay, and when we do this, we get... Be really careful with signs. It's just so stupid to lose points for multiplying with signs wrong, but it happens all the time. I might have made a mistake just now, but since I don't want to keep you waiting, I'm just going to go with it. Negative 566 kilojoules. And sig figs wise, I guess I should have a 0 there, huh? Because my other two had 4 sig figs, or they had a 10th place. Okay. Let's get some help on this one. Oh, that's nice. That's all the work. Oh, I thought I'd have to explain this one. That's fun. All right. Let's try another one. All right. Delta H. James, what do we start with? He says products. Okay, we're going to start with products. Okay, we're going to start with diamond. Okay, which is pure carbon, but it's not in its standard state. The standard state is graphite, so it does have a delta H value over here on the right. Okay. So, James, do I need to multiply diamond's heat of formation by anything? He says you can multiply it by 1, but you don't really have to, and he's totally right, but I'm still going to write it. Okay, 1 times 1.9. Okay, I'm going to move this over just to make it clear that this is one of the products. We're going to put it in parentheses and add it to the other product, which is HCl. Okay, Dane, how do I do the HCl part? He says you do 4, which is the coefficient of HCl, times the heat of formation of HCl, and he's right. Okay, I might have made this too big. I'll do this down here. Okay, we're going to do reactants. Andreas, how do I do that? He says, okay, you do 1 times, because that's its coefficient, 1 times the heat of formation of methane. He's so right that that is methane, negative 74.86. Okay, and then Sean, we're going to add that to, he says nothing, because chlorine is an element in its standard state, and its heat of formation is 0. And he is right. Okay, so we're going to do careful math here, because it's stupid to lose points for uncareful math. You guys are going to check this a million times when you do this on the test. We're going to do minus a minus, so we're just going to do plus 74.86. It's kind of a weird thing with sig figs there, where all the other ones have 10th place and this one has 100th place, so we're going to stop it in the 10th place. Okay, delta H equals negative 292.4 kilojoules. Why this works is actually Hess's law. And if you go into AP, or if you want to come to office hours sometimes, I'm happy to show you an example of it. But it works because if you wrote out all these formation reactions and added them all together, you actually would be applying Hess's law. The most important thing is to know how to do it, but that is the why. Okay, how many of these do we have? One more. So close. All right. Emily Lee, how do I start? She says you write delta H equals, and then you do the products first, and she is right. 2 times negative 395.7. Okay, that's our only product. We're going to do minus products minus reactants. Okay, 2 times SO2, which is negative 296.8. If you want to add oxygen, you can. You don't have to. Okay, we're going to be careful again. Minus minus is plus. I'm rushing. You're going to come back to class and tell me I was wrong. Okay, negative 197.8. Nicole, what were my units on this one? Kilojoules, good. Could I also have written kilojoules per mole reaction, Annika? Yes. Is that the same thing as kilojoules per mole, Annika? Not necessarily. Good. Okay. All right, I think I got you all.